Hello, your 3.4 notes for today. We're going to start off by talking about equilateral and isosceles triangles, and then we're going to go into right triangles and using the hypotenuse leg postulate or theorem as a reason for proving triangles are congruent. So that is what we're going to talk about today. And then I'm just going to switch to my completed notes because it's a lot of writing that you've got to fill in. For the first one, it says, if an isosceles or in an isosceles triangle, there exists two congruent sides and two congruent angles. So that's just your definition of isosceles. Two sides are the same, two angles are the same. The two congruent angles are known as the base angles, whereas the angle between the two congruent sides is the vertex angle. So in this picture here, one vertex angle and two base angles. The two congruent sides are considered the legs, and the third side, the one that is different than the other two, is the base. Theorem 4.3 is just your isosceles triangle theorem. It's pretty simple. If two sides of a triangle are congruent, then the angles opposite those sides are also congruent. The converse of it, if you remember, converse means you are just flipping around the if-then statement. So to say it backwards, if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. So those two ideas go together, and you're going to use those a lot. Sometimes they'll give you that these two angles are congruent, so you can conclude that these two sides are the same. We'll use that a lot today. Theorem 4.5, the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. So make sure you realize it has to be an isosceles triangle, and if there's a line segment that's cutting this vertex angle in half, it's going to be perpendicular. You'll have a right angle down here. And then we have two corollaries, so make sure you know what a corollary is. It's basically like a continuation, a statement that follows directly from a theorem. So here's the basic theorem. And then to go along with that, well, to go along with these up here, if a triangle is equilateral, then it's equiangular. And of course, lateral refers to sides, and angular refers to angles. All the sides are the same, then all the angles are the same. And of course, the converse of that, if all the angles are the same, if it's equiangular, then it is equilateral.